It's pretty crazy to be here for the second time in 1 week at this awesome event. Um, this is actually my second time speaking at a public conference. First time being yesterday, so I think it will be easier today because I'm saying more or less the same thing. Um, for those of you that didn't catch our presentation yesterday on DEX trading bot on Fantom, we are Bware Labs, and today we come with a new presentation on how you can deploy a read-only node on Fantom in a professional and reliable way, and then we will show you how you can achieve the same thing in just a few steps using our platform. But first, let me make the introductions. So we have Silviu here, one of our awesome DevOps engineers. He will provide all the technical details that go into deploying a full node on Fantom. He will talk about orchestration, monitoring, and all sorts of cool stuff. And then Alex, our own CTO, will give you a short presentation on how to use the platform to achieve basically the same thing. I am Radu. I'm a product manager for Bware Labs, and I'm doing the presentations, same as yesterday, and I'm gonna try to give you an idea of what it is we are trying to achieve at Bware Labs. So basically, I'm gonna reiterate the idea behind Bware Labs. We are trying to connect API consumers or blockchain builders of whatever nature, whether they are decentralized applications or decentralized exchanges, maybe wallet providers and so on, to full node owners in a process that is mutually beneficial. In the sense that full node owners will get rewarded or paid for hosting their nodes and fulfilling requests, while API consumers and developers will get access to fast, reliable, and geographically distributed API services in a very cheaper fashion. So, why we thought to do this? Basically, you can imagine you are a developer, you have a great idea for an application, and you have just found the perfect blockchain project you want to deploy on, but as soon as you start development, you see that you don't have the necessary access to the blockchain. You can check the major infrastructure providers. They only support Ethereum and a very select few other projects. So your only solution would be to deploy your own full node and come with your own custom solution, which is fine while in development. But once you want to go in production, you have to scale up, you have to have all sorts of monitoring, and it's really a headache. On the other side, or looking from another perspective, if you're an up-and-coming project like Fantom, you want to have your users or developers, they should have access to pretty good quality services in terms of APIs. And right now, you have to do that yourself, basically, if you want to gain traction or encourage adoption. So we come with a solution to that. Basically, our solution consists of having node providers, independent full node owners, join our platform and register into an easy-to-use, robust platform and get paid for fulfilling requests and hosting their nodes. On the other side, the blockchain users, API consumers can get access to reliable, fast APIs cheaper than ever before. So basically, we have implemented a protocol that monitors and enforces good behavior on the part of node providers. And when I say good behavior, I mean we check response times, we check uptime, and of course we check data integrity to make sure everything is all right on that part. And for the nodes that match all these requirements, they get distributed the funds coming into our platform from the API consumers, basically. The platform takes a cut for this, but most of the funds go to the node providers. In the same time, once our token will be released, the node providers will be able to stake Bware tokens and increase their revenue receiving an APY. In the same time, if a node provider lags behind or something happens to it, it will get out of the pool, and the rewards won't be coming to him until he gets back on track, let's say. So I hope I gave you a pretty good idea of what it is we do at Bware Labs, and now I'm gonna let Silviu get into the technical details and show you the most interesting part of this presentation. Thank you.
Hello, everyone. Thank you, Radu, for the lovely introduction. You're getting really good at this, so keep up the good work. I'm Silviu, a DevOps engineer here with Bware Labs, and today I'm going to present you how to deploy your Fantom Read-Only Node using orchestration, containerization, and monitoring. Basically, I'll get into the technical details so you can have an insight of what we are trying to do here at Bware Labs behind the scenes. Now I'll walk you through the agenda real quick. We're going to talk about containerization first, then we're going to talk about why do we need orchestration, how we can package nicely our deployment, also why do we need to monitor our nodes and how to do that in an efficient way, and also at the end I'll let Alex present you our MVP. Now the title of the presentation contains 3 important aspects: containerization, orchestration, and monitoring. These are the 3 subjects that I'll go through during the presentation. And now I'll just go and make a deep dive into containerization. So, first of all, what are containers? Containers are a way to isolate an application with all of its dependencies and also isolate the resources that it uses. So, basically, what containerization does is help us build an application with all of its necessary dependencies and make it very easily portable and deployable in all environments. Of course, you all know that developer colleague that says, hey, my code is working on my local machine. You should test it now. And you get the code, you clone it on your local machine, you build it, and you try to run it, and then some unexpected error appears. Why? Maybe because your colleague was testing it on a CentOS machine and you are running an Ubuntu machine, or who knows why. By creating containers, you can avoid this kind of scenario by just packaging all of the necessary dependencies and making it easy to deploy your application in whatever environment you want. This will work as long as the base image of your container uses the same kernel as the host machine. So basically, if you want to use, I don't know, you have an Ubuntu machine and you are creating a Red Hat container, that will work. If you are trying to run a Windows container in Linux, that's going to turn out to be pretty difficult. Now, an important aspect when talking about containers is, of course, the comparison between deploying your application via containers and deploying it via virtual machines. First of all, what is a virtual machine? Because we talked already about what a container is. A virtual machine is basically like a computer with its own CPU, storage, memory, but these resources are allocated in a virtual way. So basically, you have a huge machine that, let's imagine it that way, that has lots of hardware resources, and then you have a piece of software, which in this diagram, diagram is the hypervisor, that allocates the necessary resources for your virtual machine. This way, your virtual machine has its own guest operating system, and you can easily run your application on it. On the other hand, containers use your host operating system. On top of the host operating system, you will see a container engine. In this case, in this diagram, you can see a Docker container engine, one of the most popular technologies over there. And afterwards, your applications can be deployed only by employing the dependencies that it needs. So you can see the difference here by running an application, app A, on a virtual machine with its own operating system, which sounds pretty heavy regarding when thinking about the resources that it consumes, compared to deploying an application that only needs its dependencies and uses the kernel of the host operating system. As a comparison, we're talking here about gigabytes in size, and here we can talk about megabytes in size. Good. So now I'm going to enumerate some popular container technologies. Of course, Docker is the most popular. It's community built, let's say. It has a huge community behind. Also, honorable mentions are Podman and Mesos Containerizer. Of course, we prefer using Docker since it's very popular. And another very interesting thing, most blockchains offer pre-built Docker images for their binaries, so you can run them in a containerized fashion. What you can see here is a Docker file, which is basically a manifest that describes how your image is built. This is a Docker file that we have written and prepared for this conference. It's for a Fantom Read-Only Node, actually a Fantom Read-Only testnet node. This can be found on our GitHub at Bware Labs. We'll tweet the repository after the presentation, and we'll make it public, let's say, this afternoon for you guys to test it out. It basically tells us how we are building the image. We are cloning the Go Opera Git repository, which contains the code necessary to build the binary for the Fantom Read-Only Node. We build it, and we just download the Genesis file, and afterwards we can start our container. Okay, now we have our container. We have our image built, right? And we can deploy a container. This is great for development and testing purposes. You just run a command, and magic, you have a running full Fantom node. But this is not production ready, right? It's only for development purposes. What happens when we want to employ more complicated things? For example, we have multiple machines that are running, and we would like to deploy our container on each of those machines. How do we know where to deploy it manually? How can we make sure that the containers can communicate between one another? How can we make sure that we are exposing the RPC of the Fantom Read-Only Node to the exterior? How can we scale? These are all problems that arise when you are trying to do it manually. The solution to all of these problems is, of course, orchestration. Orchestration helps us do and solve all of these problems that we can see here by managing how the containers are getting scheduled on different machines, how they are communicating, and how you can scale them. The backbone of such a production-ready environment that employs containers is, of course, a cluster, which is a collection of virtual machines or physical machines or hybrid, whatever you want. Think of bare metal servers, or you name it. These are the backbone of a cluster, of a container infrastructure. You have multiple nodes running, and the nodes being virtual machines or physical machines. And on each node, you can deploy one or more containers wrapped in pods. This is a very common object name in Kubernetes. What is Kubernetes? Kubernetes is the most popular orchestration technology out there. Honorable mentions are Docker Swarm and Mesos, but of course we prefer using Kubernetes since like everyone is using it, so not a big surprise there. It's a very popular choice, it's community driven, and it's maintained by the cloud native computing foundations. Now I'll make a deep dive into the popular Kubernetes flavors. We have here the self-managed Kubernetes, the hardcore version, let's say. We have the key-free-yes, the lightweight Kubernetes version provided by Rancher SUSE. We also have Minikube, which is a one-node cluster, very popular for development and testing purposes. This one you can deploy on your own personal computer via a virtual machine, and you can actually test our Fantom node deployment. And also, last but not least, the managed Kubernetes services provided by the cloud giants. I've enumerated here EKS, provided by AWS, GKE, provided by Google Cloud Platform, and AKS, provided by Microsoft Azure. Why did I mention all of these Kubernetes flavors? Because it's important to understand the difference between a production-ready environment and the development environment. We would recommend, for example, if you want to use it if you want to use Kubernetes in your production environment, to maybe go for the self-managed Kubernetes with your on-premises machines, or go for a fully managed Kubernetes service provided by one of the cloud giants. Now let us talk about our actual use case. We have here the read-only Fantom node deployment strategy. The central piece of this deployment strategy is actually the Fantom node, which is our container wrapped in a pod being the smallest, let's say, Kubernetes object as an execution unit. This pod is maintained by a deployment, another Kubernetes object that takes care of the number of replicas, takes care that the node is healthy, it gives it its main image and things like that. We can see here that we have 4 ports that are being exposed by the pod, which are not accessible by default to the cluster. We can make them accessible by using a service, which we have right here. This service exposes the 4 ports to the entire cluster. And also in the lower part of the image, we have the persistent volume, which is basically how we store the blockchain data, because we are talking of a blockchain node, right? We have hundreds of gigabytes of data that need to be there and need to be persistent. And the persistent volume claim, which is basically how we control the allocation of that storage. Now, everything being said and done, what should we do to deploy all that, to make use of our deployment strategy? Well, we would need to write manifests and the YAML language for each of these Kubernetes objects, and many more, like a configuration, config map, or whatever, you name it, and apply them manually. This isn't really a production use case. What we want to do is to automatize and make it easier to deploy all of the aforementioned. How can we do that? We can use a package manager. So in this case, I'm talking about Helm, which is the best way to find, share, and use software built for Kubernetes. This is taken from the official Helm website. It's basically the most popular package manager for Kubernetes, and it's an easy way to parameterize and customize the deployment of an application. You can template every Kubernetes object that you are creating, like service, persistent volume claim, deployment, whatever, you name it, and afterwards provide an interface to customize the way things are getting created and deployed. In this case, it's using a file called the values file, and that's how you manage to do it the easy way. You will be able to find our Helm charts for deploying the Fantom Read-Only Node on the same repo on GitHub that we'll make public on Twitter. Now, here we have a Fantom node deployment code snippet. It's basically just the way we are starting the Fantom container. You can see here that we are using the Opera command, and we are mentioning a few arguments that are important in order to make the node start. So we have here the genesis, the data directory, what kind of HTTP and WebSocket methods we are exposing, and so on. We managed to deploy our node successfully. Everything is working, at least for now. But let us think about this scenario. You are trying to use the node. Other people are using it as well. And during the night, something wrong happens. The load is too big and the CPU usage is going high. The RAM usage is going high. Or maybe your storage is full, basically making your node impossible to use. Also, what other problems may occur? You don't have enough peers in order to stay in sync, right? These are common problems that we encounter when we are deploying a blockchain node. How can we avoid them, or how can we be preemptive about them? The solution is, of course, monitoring. By monitoring, we can implement an alerting system that lets us know when things go bad. right? So when I see the CPU usage go over 80%, I get a text message or a Slack channel notification, or maybe an email telling me about that. Or when the sync state is, or when I'm getting stuck, right? When the node is getting stuck, it's not syncing anymore. You also get an alert of some kind. How can we, let's say, create these alerts? Blockchain nodes expose, beside the usual RPC, WebSocket, or peer-to-peer ports, an additional port called the metrics port. Usually all the blockchains expose metrics in the Prometheus standardized fashion. Prometheus being a popular monitoring system based on time series databases. This way we'll have access to information regarding, let's say, the sync state, the number of peers, the latest block that was added, things like that. We can also have information regarding the CPU usage or storage usage or memory usage by employing something called node exporters, which are a popular way to get information regarding your Kubernetes cluster. These are already written by the community, and you only need to employ them in your cluster. What we have here is a common monitoring architecture that employs Prometheus as its central piece. We have here our Fantom Read-Only Node, which is, of course, the container that was launched earlier. It exposes the metrics on port 6060, if I'm not mistaken. These metrics are being pulled by the Prometheus server, which has a time series database and an HTTP server. Here we can make some manipulations regarding the data that we have and send them to Alert Manager. Alert Manager is, of course, an alerting system that's being developed by the same community as that developed Prometheus. It makes us, we can write rules that let us know when something bad happens. So we have some triggers that, some webhooks, sorry, that can trigger alerts to a Slack channel or a text message. And something else that we have here is Grafana, another popular tool for observability. Grafana uses Prometheus as a data source, and by employing the PromQL querying language, you can design, let's say, great dashboards to monitor your hardware resources, the way your node behaves in the blockchain, and things like that. Now, this being said, what I presented here today for you guys is a way of deploying Fantom in almost production-ready environment. What I mean by this is that you shouldn't only use what we have provided on our GitHub to deploy your Fantom Read-Only Node. Why you shouldn't do that? Because you don't have the, let's say, certainty that you will be able to provide high availability to your users. It may have some security issues if you are trying to do it by yourself, and it can represent a huge risk for both you, your infrastructure, and your users if you are trying to deploy a dApp, let's say, using a Fantom Read-Only Node, if you don't know for sure what you are doing there. So what do we do to avoid these risks caused by, let's say, the knowledge overhead, and also what can we do to minimize the costs, since employing such an infrastructure that ensures high availability and reliable blockchain data is quite expensive? What can we do? I'll leave my colleague, Alex, CTO of Bware Labs, to give you guys an idea about what you can do. Thank you.
Thank you, Silviu. Hi, everybody. I'm Alex, co-founder and CTO at Bware Labs. And I have to say that it's a great feeling being here today in front of you. Let me start by telling you a bit about Bware Labs. So the journey actually started not that long ago. It's been almost a year. And at that time, I couldn't even imagine the things that we can achieve in such a short period of time. So we started with a small team of 5, and it's extraordinary that we managed to grow our numbers at 20 highly skilled engineers now. For those of you who missed our presentation yesterday, I am going to do a short recap and on the form of a short demo. So all you need to have in order to use our application, it's MetaMask account. And I think it's safe to assume that everybody in the room already has that installed. Can you see the screen? Yeah. Okay, so what you have to do is to go to app.bwarelabs.com. As you can see, at the moment we have support for 7 different networks, and of course Fantom it's one of them. The next step is to connect with your MetaMask account. At this point, the third-party node provider functionality, it's disabled, but it will be out very soon. And in just a couple of clicks, you will be able to deploy your endpoint and start using it. So for the sake of this demo, we will be using the Fantom mainnet. You just click Create Endpoint, you sign the transaction. And in about 1 minute, it will be ready to use. Keep in mind that this is our alpha release, and it is free to use, but we had to enforce some rate limiting on the number of requests. So actually, the Fantom node will be limited to 25 requests per second. On the following release, which I already mentioned will be out soon, various payment methods will be available, designed to fulfill everybody's needs. If you struggled in the past adding a custom network to your MetaMask, we made that easy for you, and just by simply clicking this button, once the endpoint will be up and running, you will be able to do that automatically and start using the newly generated endpoint right away. And this is how you can achieve what my colleague already explained before, by just doing a couple of clicks in our application. It should be ready to use real soon. So I think this way it's much easier to get access to an entry point to a certain blockchain of your choosing, and focusing all the time that you have put in deploying a node using the method my colleague explained earlier, into actually developing your product. So now you just click Add to MetaMask, you approve, and you can see now MetaMask is using a custom network, which in turn is using the endpoint you just generated. That being said, I hope you enjoyed the demo and the presentation overall, and if you already started working on the on the hackathon application, now you know, and you find yourself in need of reliable APIs. Now you know where you can get them from. So thank you.
So if there are any questions from the room, we have a Q&A session now at the end. Sorry, we can hear you from here. Maybe take a mic.
Thank you. Hi, my name is Igor from Fantom Starter. And I was wondering, when will you put the GitHub live?
As I mentioned, I hope this afternoon we'll update our repo and make it public for you guys to use it. For now, the deployment is working, everything is working, including the monitor solution. We have all-in-one deployment, but the README file is still under development, let's say. After the README file is done, so you guys have it easier to deploy, we'll just make it public and tweet it for you guys.
On what cloud platform are you deploying?
Sorry, come again?
On what cloud platform are you deploying the product?
So we are currently using AWS.
Okay, thank you.
Hi, I have a follow-up on that. So wouldn't using AWS completely lead to a very centralized service?
Can you please repeat?
So I just heard that you guys are using AWS, Amazon Web Services, for all your nodes. Doesn't that lead to centralization?
Yes, in this form, our application is currently running with the nodes in a centralized manner, but with the new release I mentioned earlier, we will enable the third provider node onboarding functionality.
Thank you.
Any more questions from the audience for the guys? Ivan, what are you going to ask? There's a mic behind you. Turn around, he's behind you.
Yeah, thank you. So we're actually very curious about what metrics are you looking on to decide whether the node is like well-performing or it's like down or it's slow. What are the metrics?
So it really depends on what kind of node we are talking about. Do you want me to give you an example for Fantom? Okay, so basically we have, let's say, a critical alert for when the service is down. Basically, your container is restarting for whatever reason that will trigger a critical alert, let's say. We have an alert for few syncs. So when the number of, few peers. When the number of peers goes under 2 or 3 or whatever you think suits it best, you will get alerted. When the chain head stays the same for more than 5 minutes, that means that the synchronization is stuck. And that's also one kind of alert that you would like to have. And those are basically specifics for, let's say, the Fantom node. You can find them all, you will be able to find them all on our repo once we will make it public.